Artificial light on Proxima Centauri b? When the James Webb Space Telescope, JWST, began its mission in late 2021, astronomers expected breakthroughs in studying the first galaxies, the formation of stars, and the chemistry of exoplanet atmospheres. What no one anticipated, however, was a discovery that could hint at the presence of alien technology. Recently, researchers reported unusual glimmers of light coming from Proxima Centauri b, the closest known exoplanet to Earth, orbiting just over 4 light-years away. These faint, city-like illuminations detected on the planet's surface have sparked intense debate. Could this be the first real sign of intelligent extraterrestrial life, or is nature once again surprising us with a phenomenon we do not yet understand? A strange glow-in-the-darkness Proxima Centauri b has been a focus of attention ever since its discovery in 2016. Roughly the size of Earth and orbiting within the habitable zone of its small red dwarf star, the planet is a prime candidate in the search for alien life. But the recent JWST observations revealed something no one was prepared for: patches of illumination on the planet's night side that did not resemble natural geological or atmospheric processes. Instead of chaotic bursts, reflections, or volcanic glow, the pattern looked structured, uniform, and eerily reminiscent of artificial light, the kind generated by cities here on Earth. If confirmed, this would be nothing short of revolutionary. A signal that we are not alone, that another civilization has not only emerged but also developed technology capable of illuminating its world. For centuries, humanity has looked up at the stars and wondered if someone was looking back. This could be the first real evidence that the answer is yes. How JWST saw it: the James Webb Telescope is uniquely equipped to detect such anomalies. Its enormous gold-coated mirror, spanning over 21 feet, collects faint light with unprecedented sensitivity. Combined with its state-of-the-art infrared instruments, JWST can separate natural radiation from something far more unusual. Normally, rocky planets like Proxima b absorb starlight and re-emit it as infrared heat. Without an atmosphere, the contrast between its scorching day side and freezing night side would be extreme. Yet the data from JWST told a different story. Certain regions on the planet's night side gave off excess radiation, too consistent and too uniform to be explained by geological activity alone. David Kipping, an astrophysicist at Columbia University, described the finding as captivating. He noted that Proxima b's thermal cycles don't behave like a typical rocky world. The possibility that these anomalies could be artificial, produced by advanced technology, cannot yet be ruled out. Searching for an atmosphere. One of JWST's primary missions is to study exoplanet atmospheres by analyzing how starlight filters through them. In Proxima b's case, scientists are especially interested in whether the planet has an atmosphere thick enough to moderate its extreme temperature swings. If an atmosphere exists, it could contain biosignatures such as oxygen, methane, or water vapor, molecules strongly linked to life as we know it. But JWST's detection of glimmers on the night side raises another possibility. If the glow is artificial, then it may represent an advanced civilization compensating for environmental extremes by producing its own illumination and perhaps even energy systems. The telescope's ability to capture such faint signals is what makes it the perfect tool for testing these bold ideas. Yet JWST's range is limited. It can only probe a small number of nearby exoplanets in such exquisite detail. Beyond JWST, the next step: future observatories will be even more ambitious. The European Southern Observatory's Extremely Large Telescope, ELT, scheduled to begin operations later this decade, will study chemical fingerprints in exoplanet atmospheres with unmatched precision. Meanwhile, space-based concepts like NASA's HABEX and LUVOIR telescopes aim to go beyond JWST, using star shades or internal coronagraphs to block out a star's overwhelming glare. This would make it possible to isolate the faint light of orbiting planets, separating genuine artificial signatures from natural false positives such as volcanism or auroras. If artificial light is truly present on Proxima b, these next-generation instruments could provide the confirmation humanity has been waiting for. The larger question: artificial illumination in space would be a profound marker of intelligent life. Natural processes simply don't produce consistent, city-like glows on a planet's dark hemisphere. If Proxima Centauri b's glow is indeed technological, it would mark the first direct evidence of a non-human civilization. The implications would ripple across science, philosophy, religion, and global politics. Entire disciplines would need to be rewritten.